happen?
Pointer.
Saurabh, we will start. Yes. Okay, it's 3:30. Good afternoon, everybody. Can you hear me? Yeah, okay. Welcome again to the GAN course on next gen supply chains, harnessing IoT, digital twins, and AI driven simulation. This is the second day of our GAN course. Yesterday, we talked about the basic stuff, introduction to the supply chain digitalization, what is digitization, and what is digital transformation. We also discussed some industry 4.0 technologies, AI, machine learning, big data, blockchain, cloud computing, and so on. So one of the important technologies of this industry 4.0 or advanced technology is digital twin. So in today's session, we are going to talk about this digital twin in supply chains. Okay, I hope you all will enjoy this session. It's very interesting and fascinating, I would say, the technology, digital twin. So what are the learning objectives of our today's session? At the end of the session, participants will be able to understand digital twin in supply chain management. You might be hearing this term digital twin, control towers, blockchain, and all those things. But today we are going to see its history, from where it started and what is the current status of this technology. Then we are going to see the role of this digital technology in supply chain and logistics management, how we can use this technology to optimize the various operations in your supply chain, different activities that we are going to do today. In addition to that, I have got the one case study as well. So we are going to discuss that real world case study, and we will see how we can use this digital technology to solve real world complex supply chain and logistics problems. Okay, so just before we start on our session, again, let's check in before the lecture. What do you know about the digital twin technology? Let me share the presentation here. You can scan the QR code. You can scan the QR code, or you can go to the menti.com. Sorry. You can scan the QR code, or you can go to the menti.com, use the code 71399364. I can see 2 thumbs up. Okay, so first question, what is a digital twin? What do you know about digital twin? Physical replica of a warehouse, 3D printed product sample, virtual model that mirrors the real world supply chain operations, cloud storage system for supply chain data. What do you think? Virtual model. Let's see the answer. Yeah, that's correct. Virtual model that replicates your real world supply chain operations, and this virtual model gets the continuous data from the your real world system. So that's the digital twin. Which of the following technologies power digital twins? AI, Internet of Things, blockchain, big data. Select all that apply. You can select multiple options. Okay, so we have got one answer, fax machines as well. I don't know what is the use of fax machines in digital twin. Does anybody know? If you know, then I am happy to hear your thoughts on that as well. Okay, so basically artificial intelligence, Internet of Things, blockchain, big data, cloud computing, these are the technologies normally we need to develop any digital twin based model. We don't need the fax machines and all those things. Okay, so basically we need to collect the data, then we need to store that data on cloud, then we need the AI, artificial intelligence, to analyze that stored data and then make some decisions based on that analysis. So all these artificial intelligence, Internet of Things, blockchain, big data and cloud computing, these are the some of the technologies we need for digital twin. Which of these industries benefit most from digital twins? Open-ended questions. You can type your answer. Which industries benefit most from digital twins? E-commerce, Uber, supply chain, retailing, pharmaceuticals, electronics, health, okay, automobile, food. So yeah, so almost every industry, wherever you need to analyze your systems and you want to make some analysis of the historical data, you want to do the demand forecasting, you want to optimize something, you want to improve the visibility of your supply chain. So if you take retail, healthcare, pharmaceutical, automotive, any industry, there are benefits of this digital twins technology in those industries. What do you think is the biggest challenge in supply chain management today? What is the biggest challenge as per your knowledge in supply chain management? Okay, you can answer here. Okay, latecomers, you can join this quiz. Go to the menti.com, use that code. Information gap, technology integration, uncertainty in demand. Okay, good. Information transfer security, modeling and operations management, demand forecasting, managing multiple suppliers and distributors, managing global supply chain. Yeah, volatility, uncertainty. Yeah, demand uncertainty, transparency. Yeah, these are some of the challenges you can see. Because if you start with the customer side, the first the problem we face is the demand uncertainty. Whatever the techniques you use for demand forecasting, but still you cannot exactly predict the demand. Okay, so there is a gap between your supply and demand. That's the one thing. Then volatility in nature. Yesterday we talked about the volatility and risks. Okay, uncertainty involved. Suppose you are moving some goods, say from Asia to Europe or other parts of the world, you don't know what will happen in that, the transit. So that's the volatile nature. Then fluctuating consumer behaviors as well, consumer shopping behavior habits, it continuously changes. So that's another the major challenge for the companies to satisfy these the changing demands. Then information gap. What is the need to what is the need of this information? Because yesterday we talked about three important flows in the supply chain. What are those three important flows? Information. So information, how does it flow? Both direction. Okay, so if information doesn't pass to the other members, what will happen? Yeah, they cannot take the data driven decisions. Suppose I am a retailer, and if I am not telling the distributor what is the stock at my retail shop, retail warehouse, how much demand I have, then how can the distributor send the products to me? So that's why same distributor needs to means each and every member of the supply chain, they need to share the information with the other members of the supply chain. It is not mandatory to share the confidential information that will affect their the performance, profit, and all those things. But whatever the information which will be helpful, useful for the whole supply chain, like what is the demand coming, what is supply chain, what is the status of delivery, that kind of information we can very easily share with the other members of the supply chain, so that everybody gets some benefits from that supply chain. What is the primary benefit of digital twins in supply chains? What do you think? For what purpose do we use the digital twin in supply chain? Providing real-time visibility and predictive analytics. Because in digital twin, we have all three kinds of analytics: descriptive analytics, predictive analytics, and prescriptive analytics. So basically, we collect the data from the physical system, we develop the virtual model, and both models, physical model communicates with the virtual model, then virtual model gives the signals to the physical system, and then what we can do with that virtual model, we can provide the real time visibility. How much stock is available in your warehouse, where is your delivery in the supply chain, how much orders we are getting, and that will help you to optimize, enhance your operations in the supply chain. And predictive analytics, transportation cost. Basically, when you optimize the transportation cost or any other cost, so that will help you to enhance the performance of your company. Improving customer service response rate, that is not direct benefit of digital twin. I would say that is an indirect benefit. When you optimize the processes in your supply chain, your service rate will improve, the customer satisfaction rate will go up. But primary benefit is to provide that real time visibility and the predictive analytics. What is the demand forecast based on the historical data, that we can do with the digital twin. What comes to your mind when you hear digital twin? Any technology, anything, any feature of that technology? Thank you so much. Okay, somebody was saying, why do you track your online orders? What is the need of that?
We are tracking, we come to know the expected time of arrival so that we can plan our things accordingly.
Expected, yeah, expected or arrival time. Then you can manage your activities accordingly. That's why, if suppose distributor retailers, they get to know when the stock is coming from the manufacturer, whatever the loading, unloading, whatever the resources they need inside that warehouse, they plan accordingly. So that's why this real time visibility is very important. If you take the example of COVID-19, if suppliers located in China, if they don't share this, whatever the problems they are facing with the other members, how they can know that what's happening at the suppliers level? Okay, if you are a supplier, so it's your responsibility. Suppose I am totally dependent on your supply, so it's your responsibility to share that whatever the problems, informations with the manufacturer, so that I can manage. If suppose you are not able to supply me the products, I can go with the second backup supplier or additional suppliers. So that's why that real time visibility is very important. A company wants to predict machine failure and optimize inventory. Which technology should they use? Digital twin, traditional Excel reports, manual inventory checks, or just in time? Company wants to predict the machine failures, and after that they want to optimize the inventory in their warehouse. Which technology do you think that they should use? Digital twin? Yeah, that's correct. So because when you collect the data from those machines with the help of IoT devices, IoT sensors, all those things, you can analyze that data with the help of artificial intelligence. You can find out the remaining life left in that machines, all those devices. You can find out any faults in those machines as well, and you can do the predictive maintenance basically. And then you can optimize the inventory as well. Suppose if you know the real time stock available into that warehouse, if you know how much stock you are getting from your distributor retailers, you can optimize inventory accordingly. Which one is the fake case here? Siemens uses a digital twin for predictive maintenance in manufacturing. Amazon uses a digital twin to track customer emotions through AI. Tesla uses a digital twin for real-time vehicle monitoring and software updates. You want to find out the fake case here. Okay. Just now in the previous question, we talked about the application of digital twin for the machine failure prediction. We talked about the optimized inventory. And two students, they mentioned that Siemens uses a digital twin for predictive maintenance in manufacturing. And they are saying that this is a fake case. Do you think that this is a fake case? No, you can use, as I said, in the last question we discussed, the data that we collect from these machines, equipments, the AI, artificial intelligence, it analyzes that data, and then it will predict, when your machine will fail, it will do the predictive maintenance. So obviously that is not a fake case, that is a real one. What about the second one? Amazon uses a digital twin to track customer emotions through AI. Can you track the emotions through digital twin? No. That's why that's the fake case. What about third one? Tesla uses a digital twin for real-time vehicle monitoring. Yeah, we have been talking real-time tracking, real-time visibility. So obviously Tesla uses a digital twin for real-time vehicle monitoring and the software updates. So the fake case is the second one. Digital twin or not? Now I will give you some examples here, and you want to identify whether it is a digital twin or not. Okay. First one is Google Maps traffic prediction. Do you think that it is a digital twin or not? Google Maps traffic prediction. Aman, are you answering it? Okay. Digital twin or not? Google Maps, traffic prediction. What do you think? Is it a digital twin? Let's see. Why isn't digital twin? What is the digital twin basically? Virtual model of what? Virtual model of physical system. Google Map, what is a virtual model of what? What is a virtual model of what? Where is the physical system? Where is the physical system? From where the data is coming? Is it taking the data from any IoT devices, anything? No. That's why this is not a digital twin. Boeing's aircraft simulation models. Boeing's aircraft simulation models. Yes or no? Is it a digital twin or not? Yes. Why is it a digital twin? Because we have got the real aircraft. Boeing, they made the simulation, digital twin, the virtual replica of that physical model. That's why this is a digital twin. A Fitbit tracking your heart rate. Is it a digital twin? Okay, almost equal, 20-20, 50-50, okay, yes. Let's see what happens. No. Why? Any reasons? I already explained the Google Map. Now explain me the feedback tracking. If it is not a digital twin, what is it? Any idea? Real-time monitoring of what? Your heart rate, BP, all those things. It comes under the different technology. Do you know that technology? Fitbit or smartwatch, smart cars. What are those technologies? Sensors. Sensor means what? Which technology? Yeah, that's the one. IoT devices. It is not a digital twin basically. Okay, it captures the data from people, things, and then give you some recommendations, insights. Virtual model of a supply chain. Easy one. Yes, this is a digital twin. Why? Because we have created the virtual replica of that supply chain network, and then we are getting the continuous data from that real life system. That's why this is a digital twin. Netflix movie recommendation system. What do you think? Is it a digital twin? Yes, it is not a digital twin because there is no any physical systems, and we are not replicating that physical system into a virtual format. Okay, so your pre-existing knowledge on digital twin. Have you heard this terminology before? Have you read any books, articles? Are you working on this technology? Something like that. Let's see. No knowledge of the topic, little bit. Heard about it before but not studied it. Okay, so we have got some students. We have taken the basic course as well. I can see 2 students. Okay, and one student is showing that already know everything in the course syllabus. Wow, great, nice. Okay, so I would love to hear from that student. Then if you have studied, if you have used it for any problems or anything, feel free to share your experience. Okay, any specific requirements what do you want from this today's session? Yeah, anyhow, we are going to continue digital twin, all those things, but anything in your mind? So that I can focus on that specific question or that aspect. Learn simulation and modeling. Yes, definitely. I will show you that tool today. So that's very important because this whole GAN course, IoT, digital twin, AI-driven simulations. So that's all about that modeling part, modeling, optimization, simulation, case studies. We have got the case study here. Okay, study through examples and case studies. Yeah, I know normally participants, they don't like all the theories and all those things. They want some real life examples. Definitely, supply chain practical examples, real life modeling, healthcare supply chain management. Okay, great. Thank you so much for your participation in this quiz. Now let's move back to our presentation. Okay. Where is the pointer? Okay. So does anybody has any idea who has used the digital twin technology and when it was used? Any idea? Or when it was, came into the research or any other areas? Any idea? So NASA initially used the digital twin technology in 1970. In which mission? Apollo 13. So Apollo 13, this was the NASA's missions to do the landing in lunar on the moon, and they wanted to send the three the crew members to the lunars for this mission. So the Apollo 13 mission was a 1917 space flight that was intended to be the third lunar landing of NASA, but it ended up with the crew returning to the Earth in the lunar module. Very interesting example, guys. You can go to the NASA's website. All the information I have found, you can see the website here. All the information I have taken from the NASA's website. So what happened basically? It's considered a successful failure. Why? Because they wanted to send this. NASA wanted to do this. Third lunar landing. But what happened on April 11, 1970? They started the space flight. So launch date was April 11, 1917. Objective was third crewed lunar landing. Crew, these were the three members involved into their team: Jim, Jack, and Fred. NASA's mission control Houston, Texas. Okay, so they were controlling the space flight from their the office from Texas. What happened basically? So mission started on April 11th, and after 2 days, after 3 days almost, on April 13, they had a problem. What was that problem? Oxygen tank number 2 explodes, damaging tank number 1. And because of that, they lost the power, water, and oxygen supply in their space flight. Okay? So they were traveling around, I think, about 200,000 miles. Fuel cells fails, leaving the spacecraft without electricity. Imagine you are flying at 200,000 miles. You don't have the power, water, oxygen supply in your spacecraft. Now what can you do? So debris blocks star navigation, making manual course correction impossible. Means because of this, the loss of power, water, and oxygen supply, debris were coming onto their, the glass windshield, and they couldn't do the navigation as well properly. So immediate actions taken by the crew. Okay, so after 3 days this happened, so they informed their mission control, Houston, Texas. They selected the people, NASA's mission control team, they had to bring back these crew members safely to the Earth. That was their main objective, because this was unexpected problem. They had done all the testing and all those things, but despite those testings and all the the inspection they have done, they experienced this problem. So now they left that options to land onto the moon. They wanted to bring back their crew members safely on the Earth. So what they did, sealed the hatch between the command module, the crew member, and lunar module, switched to the LM lunar module lifeboat for oxygen and power, and mission control in Houston had to rapidly develop survival strategy. Now everything depends on the mission control team, those who that team based in the Houston, Texas. Now they want to suggest some strategies so that they can bring back those spacecraft, space flight to the safely to the Earth. So now, what they did, biggest challenge was how to bring the astronauts home safely with limited resources. They don't have the power, they don't have the water, they don't have the oxygen supply. Okay, and they were still trying to communicate with the mission control team in Texas. So what then mission control team did, it was extraordinary. Okay, during 1970, so the role of simulators and digital twin technology. Okay, so what that mission control team did, they developed the replica of that spacecraft, and they had all the information from that crew member, and they have given all the instructions. Now imagine if your instruction is wrong, they can lose their life. So the control team, they wanted to do all their, they wanted to explore all the options, and then they wanted to give that those instructions to those crew member. How NASA used the simulators to save Apollo 13. Mission controls used a simulator. Okay, the mission control team, they developed the replica of that space flight, and exact replica of the spacecraft to test solution before transmitting instructions to the crew. You cannot randomly say that you take this way, take this route, or you can do this one. Okay, they can lose their lives. So that's why they did all those the simulation experiments on that digital twin simulator. Key solutions developed and tested at the control room in Texas. Power conservation plan. They suggested the power conservation plan. Engineers devised a step-by-step restart sequence to conserve the battery life in the CM for the re-entry into the Earth orbit. CO2 filtration fix. The CM's lithium hydroxide filters didn't fit the LM system, so NASA simulated a fix using cardboard, plastic bags, and duct tape. So whatever the options they had, NASA's control team, they explored all those options, and they gave the instructions to the crew member. Manual course correction. Because of that debris, they couldn't do the navigation properly. Then what they did, look at this, is very interesting. Okay, normal star navigation was impossible due to debris, so engineers simulated a sun-based alignment. Do you imagine sun-based alignment method to guide the spacecraft so that they can return back to the Earth? So this is the early use of the digital technology in 1970 by NASA, and after that you can see the final challenge as well, re-entry and landing. Simulators helped mission control design in a safe re-entry trajectory. Critical power-up sequence, NASA developed a precise sequence, as I already told, to restart the CM without overloading the limited power left. And successful splashdown on April 17. So the mission was started on April 11th. They had a problem on April 13th. So after 4 days, they successful splashdown in the crew returned safely after 140 hours in space. So what are the key takeaways? Apollo 13 proved that simulators, the early form of digital twin technology. Simulators means a virtual replica of your physical system. So early form of digital twin technology can be mission critical tools for real-time problem solving in extreme condition or in the disaster management. You can, because you don't need the actual system, you can play with the that virtual model. Whatever the what if scenarios you can develop there, and you can then recommend the suggestions to make the changes in the real life system or real life whatever the model you have. So nowadays as well, NASA uses digital twin technologies for the various aircrafts. Spacecraft development used in Artemis missions and Mars exploration, then aircraft optimization, simulating aerodynamics for next-gen plane, space environment testing, predicting the material behavior in extreme conditions. Okay, so because they are flying at 200,000 miles, and then you need to do some testing of whatever the material you are using in that spacecraft. Okay, so those kind of testings without actually going there, you can do those testings here, and you can then check the performance of those materials. So that was the initial application of digital twin in 1970 by NASA. Then you can see the overall timeline of the digital twin. So 1970, digital twin concept appeared. First aerospace mission conducted by the NASA, Apollo 13. And again, why it called as a successful failure? Because they managed to bring back their crew member to the Earth safely. That was in 1970. Then in 2003, the concept, this digital twin concept has there was a professor Professor Greaves from University of Michigan. So he has defined these digital twin concepts, and then in one of the Society of Engineering conference. And then in 2010, again NASA they have officially defined the digital twin technology. What is it basically? So we are going to see their definition as well, how initially they have defined the digital twin technology. And then in after 2016, you can see the academic literature or some company reports, many definitions have appeared about the digital twin technology. And then intelligent digital twin technology. Intelligence means human AI collaboration. So nowadays we are talking about this industry 5.0 technologies, human machine collaborations. So those kind of the research is going on nowadays. So what is digital twin now? Tell me. What is digital twin? Virtual replica of a physical system. But the important thing that you get the continuous data, real-time data from that system. That's the only when you can call it as a digital twin. Suppose you are getting you have developed the one digital model, and that digital model is not connected to your physical model. Do you call it as a digital twin? No. So that connection is very important. Connection between your physical model with the virtual model. If it is continuously connected and both the information is flowing in both directions, not only the physical model to the virtual model, as also virtual model to the physical model. Why? We will see that. So first definition given by the the NASA's team in 2010, an integrated multi-physics, multi-scale probabilistic simulation of a vehicle or system. Basically, it was related about the NASA, so they defined from that vehicle perspective, probabilistic simulation of a vehicle or system that uses the best available physical models, sensor updates to capture the data from your physical systems, fleet history to mirror the life of its flying twin. It is ultra realistic and may consider one or more important interdependent vehicle system. So they focused mainly on the vehicles and how you can develop the virtual model of a vehicle and how you can connect your physical model, real vehicles to that virtual model. They focused on those things. But later, as I said, from 2016, we have many authors. They have developed the given the definitions of the digital twin, and this one is very interesting one and easy to understand as well, which was given by the Tao in 2018. As I said, digital twin defined as a virtual representation of a physical object, any process or system. Okay, so that is a virtual replica of that physical object, system or process, and it enables the real-time monitoring. Again, we are talking about that real-time monitoring. Real-time monitoring of what's happening in your supply chain, what's happening in your warehouse, what's happening in your company, that real-time monitoring. And once you get that real-time data, what you do? You analyze that data and you optimize your supply chain operations, your logistics, whatever the process you want to improve or enhance, you can do that one. So that's a very easy to understand definition. Virtual representation of a physical object, any system. Suppose bank. If you want to make a digital twin of bank, you can go to the bank, you can see how many counters are there, how many queues are there, and then you can use some IoT devices there to capture the data, how many customers are visiting in your bank, and you can create a one virtual model of that system. Okay, and then accordingly you can manage how many counters you want to keep open, how much waiting time do you want. All those things you can do here in virtual representation. Another definition given by the Professor Ivanov in 2018, virtual model that represents the state of the supply chain network in real time. Again, real time, and it shows the state of that supply chain network, integrating simulation, optimization, and data analytics to manage disruption risk. So he has focused on the risk point of view, how we can use the digital twin technology to manage the risk involved in your supply chain. So in this definition, you can see three important terms: simulation, optimization, data analytics. Now tell me, how are these three technologies, simulation, optimization, data analytics, how these three are related to the digital twin? How you can use these three technologies in digital twin? Tell me. What is the use of, okay, let's start with the first one. What is the use of simulation in digital twin? Why do you need the simulation?
We create complex scenarios,
Estimation of that specific scenario, complex, yeah, because when your system is very complex, you cannot do the analytical analysis. For example, if you visit a bank and there is only one window is there, only one counter is there, and only one queue is there, you can very easily do the analytical calculation. You can use the queuing theory formulas. You can find out the server's ideal time. You can find out the length of the queue based on the arrival and all those things. That's easy and simple system. But suppose if you see the airport example, how many counters are there? Suppose 50, 60, 100 counters are there, and you have got so many queues are there. Can you do the manual calculation? No. Then you need something to analyze that one. So what? You can create a virtual model in a simulation or any other, software, and then you can analyze there. Okay. So that's why simulation, to create some what-if scenarios to analyze that complex system. That's why you need simulation. Okay. And what is the purpose of optimization in digital twin then? Getting the best out of all the feasible solutions. Okay, that's basically optimization definition you are saying. What I am asking, that's correct, optimization definition is correct, but what I am saying, what is the purpose of optimization in digital twin? For what purpose do you use optimization in digital twin?
When we create some scenarios in simulation, then we'll try to explore the solutions for those things.
Okay.
So out of those solutions, we'll evaluate which one will be the good. So through this optimizations and provide them.
Okay, so you can create, means you are saying with the help of simulation you can create some 4 or 5 scenarios, and out of those 4 or 5 scenarios you can say that which one is best one, optimize. Okay, but I can with the help of the simulation, when you do the simulation, I normally get some KPIs, performance indicators, profit, cost, and all those things. Based on that, I can directly select. Suppose there are 4 scenarios are there, and you are calculating the profit for each scenario. I can see the profit of all 4 scenarios, and I can decide, okay, whichever is the highest profit, I will go with that one. Why do I need the optimization there? I will give you one example. Okay, suppose you are modeling or suppose simple case, you are moving something, say for example Varanasi to Mumbai or Delhi. Okay, one simple example, your job is to move the goods from Varanasi to Mumbai or Delhi. Okay, so scenario you are developing, scenario means you are saying that, okay, you are taking one route. Okay, you are taking one route, whatever that route, from Varanasi to Mumbai, for example. Okay, so simulations, you can say, okay, what happen if there is a disruption in that route? You need another route. Okay, or if your vehicle is breakdown or there is accident, some kind of these simulation scenarios you develop. Okay, and then you can find out the total time required to reach from your Varanasi to Mumbai. Okay, that's the one. Optimization, what is the purpose of optimization? Suppose when you had that problem, unexpected event in your system, and whatever the resources available at that point, optimization, it considers that the resources and give you the best solution. Okay, suppose you are going from one route, and if there is a problem, so you don't need to do anything there. The optimization model will find out the alternative shortest route from point A to point B, and it will give you the solution. Suppose another example, suppose you have got those 4 suppliers, okay, getting products, raw material, components, and if one of the suppliers stopped you supplying the products, now what to do? Only you have got only 3 suppliers. What to do? Now you want to again optimize your network considering that 3 suppliers. So that's the use of optimization. So optimization, and again real-time data. Real-time data means in normal case all supply chain members, they work fine. Okay, but something happen, then that unexpected events, that data will go to the your the AI, artificial intelligence. Then optimization tool will consider that whatever the data available, only 2 supplier, 3 supplier, or if your DC is closed, and then it will optimize the network considering that available assets. So that's the use of optimization. Data analytics, again, to analyze that collected data and to provide some insights. So here you can see that network. Okay, this is a physical world, physical supply chain. Okay, and then this is a digital world, a virtual representation of your physical world. So what is this communication layer? Whatever the data is generated here in the physical system, physical object, we need to transfer this data to the digital world. So if suppose you miss any important data, any important feature from this physical world, and if your virtual model is is different than the physical model, then there is no use of that digital twin. So whatever the real-time data is there, so you need to transfer that data to the virtual model with the help of some communication technology, IoT, sensors, all those things you can see here. Then information sharing. What is the use of this, guys? What is the information sharing? What does this virtual model tells the physical model? Yeah, that's the one. Okay, so whatever the data we are transferring from the physical model to the digital model, virtual model, they will virtual model, digital twin will analyze that data, whatever the data they get from the physical model, and then they will recommend him some solutions. Suppose if you take the example of that Varanasi to Bombay, if you are moving something, if suppose that route is affected, then that data is passed to the digital model, digital twin. Digital twin do the the optimization, and it will tell you, now you take this route. This is the shortest route. There is no traffic on this route. You can do this thing. Okay. So then that information will go to the physical model, and then that physical model, they will take the action based on that, whatever the recommendations given by the digital twin. Is it clear? So if you want to see some other definitions for the digital twin, so you can find some other definitions as well here. I have just given for your information, but some important definitions we already discussed here. But if you want to see something like, you can see the simulation of a physical object itself to predict future state of the system, or second last, digital representation of a real world object with focus on the object itself. Product digital counterpart. So many interesting definitions are given, and again based on the area, in which area you are talking about this digital twin. So levels of integrations. Digital model, digital representation of. Now tell me the difference between digital model and digital twin. Complete digitalization. partly correct. Yeah. Anyone else? What is the difference between digital model of any object and the digital twin model? We already discussed these things, guys. We have been talking about. Digital model is simple digital representation of a physical entity. Suppose you are creating the digital model of any bank or any hospital or anything, any warehouse. In warehouse, how many doors are there? How many counters are there? All those things. You are creating just digital model. In a computer model, you are creating the model. That's simple one. But are you connecting that physical with the digital one? No, you are not connecting. This is just digital model for the analysis purpose. You want to see, okay, how it looks and all those things. That's the digital model. What is the digital shadow? Digital representation with unidirectional. Again, look at those keywords. Digital model means there is no information flow. Digital model means there is no information flow from your physical to the virtual and virtual to the physical. Digital shadow means information goes in one direction. A digital representation with unidirectional information flow from physical to virtual. So whatever the data available in the physical model, you try to get that data into your digital model. That is called digital shadow. And what is digital twin? Two-way direction, two-way information flow. So don't forget this one. If somebody is saying, or if you are using these terminologies, I have developed the digital model of supply chain. Do you say the digital model? No, digital twin model you have developed when you have the both way of information sharing. Any doubts? All clear? Okay, so types of digital twins then. Okay, so digital twins is a virtual representation of physical object, your systems, or something else that connects the physical world with the your virtual world. So there are various types of digital twins in supply chain and operations management. So what is the first type? Is the product digital twin. Its name suggests that the digital twin of a product, digital twin of a spacecraft, digital twin of any car, or digital twin of something else, one single object or product. If you are making the digital twin, digital model of that product, so that is called product digital twin. Models a single product or component for quality control and predictive maintenance. Normally we do this kind of modeling in CAD/CAM, PLM, product life cycle management, digital thread, and the software you can use the Siemens Team Center. The example is aircraft engine. Okay, suppose if you want to make a digital twin of aircraft, that is called product digital twin. Now next one is the process digital twin. It simulates the manufacturing. So in supply chain you have got the manufacturing, logistics, warehouse, different processes. So if you want to simulate, if you want to create a digital twin of that one specific process, it is called process simulation. Process digital twin. Simulates manufacturing, logistics, or warehouse operations to optimize efficiency and workflows in your supply chain. And the examples are manufacturing execution system, where you can simulate or you can model that whole manufacturing plant. So this is a process based. So you have got procurement, manufacturing, distribution, logistics. You can create the digital twin of that one specific process. Got it? So what are the tools available? You can use in the AnyLogic and Flexim. These are the software you can use to model the process. Suppose you want to model a one manufacturing plant. In AnyLogic, you can do that modeling and you can define then how many workers are in that factory, how many machines are there, how much time is required to move from one station to another station. All those things you can define in that AnyLogic model, and you can then analyze that system and see the performance. Then company-wide digital twin. Company-wise, it represents the entire organization. Have you heard the ERP term, enterprise resource planning? So in ERP, you can find the details of all the information available in that company. So this is an example of company digital twin. Represents an entire organization for strategic decision making and enterprise-wide planning. Example is ERP, business process simulation or cloud platforms. So SAP Digital Twin is very famous for the company-wide digital twin. Then supply chain network. Supply chain digital twin digitally mirrors the ends-to-end supply chain, from supplier end to the customer end. When you are considering all the members involved in that supply chain, all the third parties, fourth party logistics provider, all those members, and when you create that model, it is called supply chain digital twin. You can do the risk management, resilience planning there, software or supply chain management software, AI ML based forecasting, and then one of the important software is any logistics. That we are going to see how we use this tool. Then fifth and last important one is the network of networks. What is the network of networks? Connects multiple supply chain and industries. Suppose you are making two kinds of products. One product, as I said, each product has its own supply chain. One product you are selling through the normal physical stores, and one product you are selling the online one. Okay, obviously network is different, and you want to optimize both network together, online one and offline one. Or if you have got, suppose you have the parent company and you have got your another company, and you want to jointly optimize the network of these companies, so you can do that in the network of networks digital twin. It connects the multiple supply chain and industries, optimizing the collaboration and ecosystem resilience. So blockchain, edge computing, AWS, IoT, Twin Maker, Google BigQuery, these are the some of the tools available if you want to model this network of networks. Okay, so if you look at the complexity level, starting with the product digital twin, very easy, modeling in the CAD CAM, and then you can connect it. Then process level, again company level supply chain. Difficult, high complexity level at the network of networks, because you have got the multiple supply chain networks, and they have got all the complexities, and when you are trying to optimize jointly, it is very difficult. So now we are going to see one case example, hypothetical example, to see the difference between the physical world, physical supply chain, and the digital virtual representation of your supply chain network. Suppose there is one company, Speed Auto Motors Private Limited, hypothetical company, is an automobile manufacturer in India specializing in electric cars making. Okay. So this company sources components from two key suppliers, and assemble the vehicles in Pune factory, distributes them via 3 regional distribution centers, and to serve 4 customers across India. So how many members are present in this supply chain network? How many members are present? 4. Who are they? Supplier, manufacturer, distributors, and customers. So 2 suppliers are there. Supplier A located at Delhi, and that supplier provides the batteries and electronic components to this Pune-based factory. Second supplier based in Chennai, that supplier provides the metal frames and body parts. We are just, this is a simple example I have considered. You might ask me, what about the tires and other things? This is just for, the explanation purpose. I consider only 2 suppliers. But in real life, there are thousands of suppliers involved in automotive supply chain. So next one is manufacturing factory, which is located at Pune, Maharashtra. So it assembles the electric cars with supplied components. Then distribution centers, we have got 3 distribution centers. One is Mumbai, that serves West and Central India. Bangalore serves South India. Kolkata serves East and Northeast India. Customers, these are not the normal customers. These are the dealers, okay? Basically the dealers. And then you can see 4 dealers are there. One is Ahmedabad, another one is Hyderabad, Delhi, and Chennai. Now, if you want to model this in a physical world, normally. So basically, before that, what are the challenges in the physical supply chain? Lack of real-time visibility of shipments from suppliers. So we have got the 2 suppliers, And normally this company is facing some problems when the supplier sends the delivery to the manufacturer. Okay, they don't get the real time update where is that delivery, how much time they take to reach to their manufacturing plant. So lack of real time visibility of shipments from suppliers, high inventory holding cost due to inaccurate demand forecasting. If your forecasting is not correct, what happens? Tell me, do you know the trade-offs in supply chains? What are the some trade-offs in supply chains? Any idea? What are the important trade-offs in supply chains? Efficiency and responsiveness. Yeah, that's correct. If you want to increase your efficiency, what would you do? Yeah, you minimize the inventory, so you minimize the inventory cost, inventory. That's right. So you are focusing on the efficiency. But what about the responsiveness then? Suppose customers wants the product on time in one day. Can you do that? No, you can't do that. Why? Because you are keeping the low inventory in your warehouse, and when you experience the sudden demand from customers, you cannot fulfill that demand. So there is a trade-off. When you try to minimize something, other the whatever the KPI you are considering, it gets deteriorated. Another example is inventory and transportation cost. Do you know these two terminologies, less than truckload and full truckload policy? What is it? What is less than truckload and what is full truckload? Yeah, that's correct. Less than an FTL. So which is better for supply chain? Full truckload. From which point of view? Supply chain. Suppose your transportation cost is very high. Your distributor wants suppose 50 products, and your transportation cost is very high. So you as a manufacturer sending 100 products to the distributors because your inventory cost is very low. You want to minimize, optimize your transportation cost. The demand at distributor level is only 50 products, but still you are sending the 100 products. Why? Because you want to save the transportation cost. That's the purpose. But again, when you try to minimize this inventory cost, the transportation cost will go up. When you minimize your transportation cost, your inventory cost will go up. So you need to find out the trade-off between these the KPIs. So higher inventory cost due to inaccurate demand forecasting. If your forecasting is not correct, you keep additional stock or you may face the out of stock problems. Production bottlenecks due to delayed supplier deliveries. If one of the components is delayed because of the some issues from suppliers, you cannot make the production. So this is a physical supply chain of that our Speed Auto Motors Private Limited. So we have got the two suppliers. One is located at Delhi that supplies the electric batteries. Another one is at Chennai that supplies the body parts and other parts. Then factory is located, Pune. We have got 3 regional distribution centers, Mumbai, Bangalore, Kolkata, and then we have got the 4 customers dealerships. So this is a physical supply chain. Now I want to create the virtual replica. How would I create that one? And where do I create that one? Not digital twin. I am not saying digital twin. Why I am not saying digital twin? Because I am not saying that we are connecting these two physical model with the virtual model. I am just saying that I want to create the virtual replica of this model. Where do I create it? Do you know any software, any tool? Arena. Okay. Anything else? Stella, System Dynamics. Okay. So yeah, Arenas, Stella, these kind of simulation tools you can use. But as per my knowledge, Stella is based on the System Dynamics simulation model. Okay. So there are different kinds of simulations: discrete event simulation, agent-based simulation, System Dynamics simulation. So it depends on what kind of problems you are solving, because you cannot solve every problem with that one kind of simulation. Okay. Suppose a long term objectives you are exploring. Suppose if you want to find out the population growth in next 50 years, next 30 years or 40 years, then you can basically use your system dynamic simulation. Or if you want to find out the GDP in next 5 years, 10 years, those kind of things you can do in the agent system based simulation. Agent based simulation means, suppose if you want to find out the behaviors of your supply chain members, then you can go ahead with the which simulation? Agent based simulation. Okay. Discrete event simulation, suppose normally in the queuing system we see this arrival rate and then the departure rate, all those things. If you want to model your system in that way, or if your problem it falls into that category, then you can go ahead with the discrete event simulation. So now you can see here supply chain digital twin. This is not basically digital twin, this is a virtual representation of that physical model. So I have created this model in any logistics tool. I will tell you about what is that tool, how you can create that the digital model there. So this is your physical supply chain. We have got the 4 entities here: supplier, manufacturer, distributors, and then customers. So tell me, where are the suppliers located here in this virtual digital visualization model? Delhi. Where is Delhi? Sorry. So can you see the green symbol there? Yeah, just give me 5 minutes. Yeah. Can you see that green symbol? So that symbol is for that icon is for your supplier. Then this is Chennai. Okay, so this is the Chennai based supplier, and you can see where is the factory located? Pune. So this is your factory. This is your factory located to assemble the electric car. And where are the distribution centers? So this is your Mumbai DC, this is your Kolkata DC, and this is your Bangalore DC. Got it? Then how many customers are there? 4 customers. Ahmedabad customer, Delhi customers, this small icon, can you see it? So these are your customers. Okay. So you can then visualize this your model, supply chain network. Basically this is just to show that how your virtual model looks like. See, this is your physical model and this is your virtual model. Okay, so now if you want to connect it, or if you want to make it a digital twin kind of thing, so they in this any logistics tool you have got so many options to define the parameters. So for example, if you say suppliers, so you need to see what kind of products, raw material components that supplier supplies to the manufacturer, what is the lead time, what is the capacity of that supplier. Similarly, when you see the manufacturer means you can define the bill of material. Bill of material means how many products, raw material components you need to make one finished product, and what is the production cost, what is the production schedule. All those things you can define in the your factory. Distribution center, what is the important parameter at distribution level? What do you do at distribution center, guys? Where do we keep the inventory? We keep the inventory at customer level. Am I right? Why? Why don't we keep the inventory at customer level? We don't keep the inventory at customer level, basically. We keep the inventory at distribution center. So do you know the inventory policies? What kind of inventory policies do we normally use? EOQ policy, okay. Which one? MN. What is that? Minimax, max min, what is it? Okay. So basically there are a couple of inventory policies. As you mentioned, EOQ policy is there, cross docking is there, minimax policy is there, SS is there, small s, capital S, minimax, then RQ policy is there, reordering point, and then quantity you want to order. So many policies are there. We are going to talk about those things. And the customer level, we define the what? What do we define at customer level? Demand. How much demand, how much products they want. Demand could be your what? 2 types of demand. It could be, okay, anticipated, but normally deterministic, and what is the second one? Stochastic nature of the demand. Okay, or if you have got the historical demand, you can feed that data into this tool, and then it can forecast the data based on that historical demand as well. Okay, so that's the your customer level parameter defining. Okay, so now we will take the 5 minutes break, and then we will restart. Okay, in 5 minutes. Okay, students, we will resume our session. So this was the difference between your physical supply chain and the digital visualization of supply chain. So now we are going to talk about the how we can use digital twin in supply chain and operations management. What are their applications and all those things we are going to discuss now. So basically, as I said, so we can do the real-time tracking of the shipments, then inventory, all those things with the help of digital twin in supply chain and operations management. It is a solution for better visualization and understanding of supply chains and opportunity to further analysis, simulation, optimization. We already talked about those three things. What is the use of simulation, optimization, and then data analytics in the digital twin. We can analyze that your supply chain virtual model, and then you can do the optimization, and we can enhance the systems. Combination of multiple enabling technologies. So for digital twin, you need couple of technologies. You cannot simply rely on one single technologies for the digital twin. Why? Because you need to collect the data. Once you collect that data, you need to store that data somewhere. After that, you need to analyze that data with the help of artificial intelligence, machine learning algorithms, and all those things. Then once after that analysis, you need to provide some recommendations to the physical world, and then they will take the actions based on your recommendations. And after that, taking that actions as well, you need to continuously monitor that situation. Why? Because suppose AI suggested something to the physical world, and you have taken that action, but because of that action, if something unexpected happen, then again that unexpected situation will go back to the physical world. The AI optimization, they will analyze that data, and again they will recommend the new strategy to manage that event. So it includes the multiple enabling technologies such as sensors, cloud computing. We are going to talk about those technologies. Couple of important technologies we need to develop the digital twin of your product, process, supply chain, or any company. This is a computerized models that represent the network state for any given moment in time. Suppose if you want to find out the, again, dynamic nature, real-time tracking of the data. So if you want to find out the, what happened at that particular point of time in that supply chain network, you can do that with the help of digital twin. So again, we looked at couple of definition, but if you, again, this Professor Ivan now, he has given very nice and interesting definition of digital supply chain twins that covers the 4 aspects. What are those 4 important aspects? A digital twin of a supply chain is a virtual system, virtual replica of your physical world. It includes, first one is the digital visualization of a physical supply chain and its elements. So virtual representation of your physical objects. And when you say the virtual representation, suppose if you want to create the virtual representation of your physical network, now in the previous, that hypothetical case, what we did, we model who are the suppliers, who are where is the factory, who are the distributors, who are the customers. But in addition to that, you need to model the flows as well, because money flow, information flow, product flows. So you need to model the flows, planning, control algorithms, forms. So that's the first important component in your digital supply chain twin. Okay, virtual representation of the physical objects. And when you are making that virtual representation, you need to make sure that you are exactly replicating what is there in the physical system. Suppose you are considering the supply chain, how many products are there, how many suppliers are there, how many vehicles they have, how many warehouses they have, what is the capacity of each warehouse, how much time they need to move goods from one point to another point. All those things you need to consider, and then you need to define those inputs in your virtual model. That's the first one. Then second one is the digital technologies, providing data about the physical objects. We need to collect the data, so we need some digital technologies. We need the sensors, blockchain, clouds to keep that data. So that is the second important component, digital technology. Internet of Things, blockchain, sensors, cloud, ERP. Third important component is the descriptive, predictive, and prescriptive analytics for decision making. So what is the purpose of descriptive, guys? What do we do in the descriptive analytics?
Take all the historical data. We'll try to get the summary of the data. Or
Insights from the that data. Basically, we try to find out what happened in the past, why it happened. That is a descriptive. You find out the mean average of the orders, products you received from the supplier. If there is a problem from the supplier, you can say that one of the supplier is not supplying you products on time. You can find all those information insights from the historical data. That is your descriptive analytics. What is predictive analytics?
based on the historical data, try to predict the future.
Right.
It's going to happen.
Okay, predict the future. That's correct. Any example?
So based on the previous sales, if I say,
Mm-hmm.
so next 3 months, how the sales are going.
Sales. Yeah, forecasting. Demand forecasting is the best example of the your predicting the future. So how much orders you have received, how much sales you had in last 3 months. Based on that data, you predict for next 3 months, next 1 month. That is predictive one. What is prescriptive analytics? Any guess?
That predictive thing, what has to be done?
To satisfy that demand. Suppose your forecast is saying that next month's demand is 1,000 products. Now you need to see how much resources available in your warehouse, in your factory to make those 1,000 products. And if you want to, and then you want to optimize your resources to make that, to satisfy that forecast. So that's your prescriptive analytics. So basically, again, as I said, here the three important components. First is the virtual representation of physical objects that you can see. Then we need the digital technology, and then we need these three analytics: descriptive, predictive, and prescriptive analytics. That's why I was highlighting simulation optimization. They are part of what? Which analytics? Simulation and optimization. Predictive or prescriptive, you could say. Predictive because simulation we can predict the future, that's why simulation. But optimization, mostly it comes in the prescriptive analytics. Then a digital twin is linked to a real object. We already talked about it is linked to the real object or real system or real the model. It gets continuous data exchange, ensures the digital twin behaves synchronously with its real counterpart. That's why real-time data, it makes sure that your virtual model exactly replicates what is the real world system. Okay, if there is any lag or there is any delay in the getting that real-time data from your physical world, then virtual model will recommend something else. So that continuous sharing of data from the physical world to the digital model is very important, and that's why these digital technologies, IoT technologies, then cloud computing, all those technologies, they play important role in this communication. Both the digital twin and the real system influence each other. We talked about two-way information sharing. Physical model, then it goes to that information to the digital world. Digital model, virtual model, digital twin model. It analyzes the data and then recommends something to the physical world. Mirrors the state and performance of the real system. It can send control signals. We already talked about control signals back to the real system. It recommends, you take this route, you manage your resources, or you open your new DC to satisfy this demand, and all those things. Digital twins support decision making in 3 areas. So we already talked about descriptive means performance visualization. What happened in the past, why it happened, what is the reason behind that high demand or high orders or high sales. Predictive one, demand forecasting. You can do the demand forecasting, predict the future. And then prescriptive one, supply chain recovery simulation and optimization. So there are a couple of important terminologies. Again, digital twin data, it plays the important part in the digital twin. And digital twin, it leverages the real-time technology to enable data collection, analysis, visualization, and creation. So it integrates we already talked about optimization, simulation, visualization in a cohesive framework. So here in the previous that the supply chain case, we have seen the virtual representation of that physical supply chain. Now when you actually connect that physical supply chain to the virtual sub model, and then you run that model, you can see how products are moving from one location to another location, what is the inventory building up at each warehouse, whether you are satisfying the demand or not. All those KPIs, visualizations you can see on that your digital twin network. It includes the internal data processing as well, and then sometimes it collects the external data as well. It serves as a knowledge-oriented system facilitating knowledge transfer, generation, and application through human-machine interactions. So this is one basic conceptual design or conceptual framework for digital twin in logistics and supply chain system. So here you can see the physical, your supply chain. You have got the raw material suppliers, then suppliers, main suppliers, they make the components using that raw material, then manufacturer, they make the finished products, then send to the distribution, retailers, consumers. So this is your physical layer, physical supply chain. Then now you want to create the digital layer, means digital twin. So you want to then make that, the digital layer in some kind of simulation tool or some modeling tool, as I said, any logistics arena or something else. Then this is your raw material supplier, main supplier, manufacturer, distributor, and the two-way interaction, communication layer. Okay, so all the information from this physical layer, it gets transferred through the digital layer with the help of IoT devices, RFID sensors, all those things, and then they analyze that data, they recommend something, and then that recommendations come here, and again you take the decisions based on those recommendations. So just again detailed analysis how it works, basically all the three the decision making stages. So what is this time t1, time t, and time t plus 1? We are talking about real time tracking of the inventory, real time tracking of shipment. So t minus 1, t is the current your time period. So suppose your time period is weekly basis. So this is your current week, t minus 1 last week, t plus 1 next week. Okay, so in the previous week, sensor means IoT devices. Okay, RFID QR code. What they do, they collect the data from the whatever the the supply chain network, and then what it does, that data it flows through the digital layer. Okay, then what is the first thing you do when you get the data? Descriptive. Analyze that data. What happened? What what orders you received from the customers? Why you received that order? Was there any peak or something? That's why you received higher orders, lower orders. You do that analysis in descriptive. Then after that, you pass that information to the predictive analytics. Then predictive, based on that historical data, it will predict the future. It will predict the demand. Okay, next week's demand will be say 500 or 600 based on the historical demand. That's your predictive. Then once this is done, what is the control flow? Predictive is demand is forecasted, predicted. Then it basically goes to the prescriptive one. Then optimize your resources, optimize your supply chain to satisfy that demand forecast, whatever the forecast is there. Okay, once you've done that, then then after that last stage is the actuators. Then you start managing your resources, whatever the cost you want to minimize. So that's actuator, and then this is the whole the steps, whole steps of your data flow, and how these three analytics techniques work in the digital twin. Similarly, if you look at the current week, so the last historical data comes here from the previous one, and then again whatever the sensors, the data they get from this week, it goes to the descriptive one. Then these descriptive analytics here, it doesn't only consider the data from this sensor. It will consider the data, historical data as well. Historical data from the last week, then what is happening from here, that data, and then they do the analysis, and then again predictive one, prescriptive one, actuator, and then it goes to the physical layer, time t+1. So this way, your analytics, your descriptive one, predictive one, prescriptive one analytics, they play important role in your digital twin. So digital twin technologies. Okay, we have been talking about the digital twin technologies. So now, what are the important technologies in the digital twin? So 3 key aspects of digital twins. First one is the data acquisition. Collect the data from the physical world. Collect the real-time data from physical objects, physical system, data acquisition. Then data modeling. Once you get the data, you analyze that data, you find out what happened, what was the demand, orders, and so on. Creating a data modeling means creating a digital representation of that physical, object. Then third important aspect is data application, using analytics and AI to optimize the performance. Once we get the data, you model that data, and after modeling, then use AI optimization to to enhance your operations to satisfy that forecasted demand. So 4 core technologies powering the digital twins. What are those 4 important technologies? So obviously first is Internet of Things. Why do we need it? To capture the data from the physical object, physical system. It connects the physical and digital worlds using sensors, RFID, QR codes. It easily scan the information available on that packaging and transfers to the cloud. Real-time data collection from monitoring and updates. By 2027, 90% of the IoT platforms will support digital twins. Nowadays, some platforms, IoT platforms, they are not directly connected to the cloud. They capture the data, but they are not connected with the clouds, AI, and all those things. But by 2027, 90% of all the IoT platforms available, they will be connected to the digital twin platforms. So you don't need to do anything additional to connect that one. Next one is the cloud computing. So why do you need the cloud computing, guys? To store the data. Why don't you store at your PC local level? Capacity. Because the data you get from these physical objects, the physical objects or physical systems, huge amount of data. Yesterday we talked about the big data. There are 5 important V's. Normally we see big data means huge amount of data magnitude, but there are variety of different kinds of data is there. Then velocity of data, the speed at which that the data is generated, and what are the insights you get from that data. Okay, so that's why this is not normal data, one Excel sheet or 500 rows or 1000 rows. It's not that kind of data. Okay, you have got millions of data is there, rows are there, observations, and every day. Imagine if you take the automotive supply chain, 1000 suppliers, and they are reporting all their deliveries, shipments, their information about each small parts, components. How could you save that data in a small Excel file or your locally? Okay, that's why you need the cloud computing, so that you can store that data, you can manage that data, because normal your data mining techniques, you cannot manage that big data with the normal techniques. Provides the data storage and computational power. Enables the global access to digital twin data. So anybody who has the access to that cloud computing, they can easily access that data, and they can see what happened in the past and what we are doing. Helps process large data volumes efficiently. As I said, big data, we cannot manage that data efficiently with the normal techniques. That's why you need that big data analytic techniques. So what is the key takeaway? Digital twins rely on IoT and cloud for real-time monitoring and data accessibility. So these are the first 2 important techniques. IoT to capture the real-time data. Once you get that real-time data, you need to store that data, you need to process that data, you need to analyze it. That's why you need the cloud computing. What is the third one? AI and extended reality in digital twins. Why do you need the AI now? You got the data, you stored it, you analyzed it. Now what? To automate the processes. Key technologies for intelligence and immersion. You can see artificial intelligence, it analyzes digital twin data for prediction and insights. Okay, once you store that data at the cloud, in the cloud, you need to analyze that data, you need to predict the future, you need to find out some insights, hidden patterns and trends from that data. So machine learning algorithms can analyze that data and then propose some the insights. Uses machine learning neural networks and deep learning algorithms. So that's the use of your machine learning. Many times, sometimes I would say, if you ask students what are you doing, so they ask, okay, I am doing machine learning, I am doing artificial intelligence, but they don't know what is the use of this machine learning or the artificial intelligence algorithms in the digital twin. Okay, so see the broad picture and then you see what is the role of that machine learning algorithms in your digital twin or in your digital supply chain. Okay, so machine learning algorithm, neural networks, deep learning, we are going to talk about these machine learning algorithms, all those things in this GAN course. So these are the techniques, algorithms to analyze that data to predict the future. Helps in predictive maintenance and risk analysis. Another very important, predictive maintenance. Suppose you are running a factory and you want to avoid the costly failure, machine breakdown. You can use the IoT devices on that machines. You can get the data. AI will analyze the data and it will tell you when will your machine may fail. It will ask you to do the predictive maintenance, risk analysis as well. The AI will predict the disruptions. Suppose based on the historical data, as I said, suppose you have got 1,000 suppliers. Out of those 1,000 suppliers, if suppose 100 suppliers are creating the problem, how do you know that 100 suppliers are problematic? How do you know? Through data only. Look at the data, look at the historical data. If 100 suppliers are creating problem, means maybe there might be problem with their quality, the quality of the components they are sending, or they might be delaying their shipments. So when you analyze the historical data, you can find out that, and then you can say that, in the future, these 100 suppliers may create the problem to you, so you need to do something else. You need to go with the backup supplier, or you need to change these suppliers. So that's the prediction of disruption. So AI will do that by analyzing the historical data. Extended reality. Again, important technology. It combines the virtual reality, augmented reality, mixed reality. It creates immersive, interactive digital models. So suppose if you want to do some training or something else, you can use these kind of technologies and then you can provide those training. It enhances real-world simulation for training and testing purposes. So these are the 4 important technologies in digital twin: IoT, cloud computing, artificial intelligence, and then extended reality. Okay, so in addition to that, nowadays, if you look at the academic literature, some authors, they mention that you can use the blockchain as well. Basically, blockchain means for transparency and secure transactions in your supply chain. So that is also you could say another technology that can be used in the digital twin. So how these technologies work together? Tell me. IoT sensor provides constant data transmission from physical world to digital model. Next one is the cloud. Cloud enables storage of data that could be easily accessed from anywhere, and anyone in the supply chain, they can access the data. I don't need to call my supplier and I don't need to say what is the status of my delivery, when will I receive the delivery, whether it is in a good condition or not. Okay, how do you make sure that your products are in good condition with the IoT? Any idea? Suppose you are transferring the perishable products, say for example COVID-19 vaccine, that needs -70 to -80 degree temperature. Suppose you are moving that vaccines from your supplier, from distributor end to the retailer end. How do you make sure that it is in a good condition? Yes, so sensor basically, again, IoT devices, it will continuously monitor the temperature inside that container, and if it temperatures goes above that limit or below the whatever the the threshold you have set, it will send the signal to the your main the whatever the app or platform, and it will ask you, or sometimes it will automatically adjust the temperature as well. So that's the again very good application of your digital technologies. Then AI analyzes, capture data, provides insights and makes prediction. XR means extended reality allows digitally modeled physical objects. So if you look at the flow here, so initially IoT collects the real world data from the physical model, physical system. Then we store that data, collected data, into the cloud stores. We process that data. Then the next part is AI, artificial intelligence, that analyzes that data and predicts the future, predicts the demand, predicts some disruption, something else. Then after that, extended reality visualizes the digital twin models. It will look like that. So that's the the total flow of those four technologies. So AI and XR enhance decision making, predictive analytics, and real-time visualization in digital twins. Some use cases and benefits of digital supply chain twin. So for transport planning, application area transportation. So you can do the supply chain mapping. Transportation means you can do the supply chain mapping, and you can do the real-time tracking of your shipments, synchronization, simulation, decision support. Benefits: transparency of transportation basically. As I said, you don't need to call your supplier or distributor to ask them the status of your delivery, or you don't need to ask the driver, okay, whether the temperature in that container truck, whatever the lorry is there, is it within that range or whether it is beyond that range. It will automatically tell you. Transportation flexibility as well there. Transportation flexibility means, suppose you are taking one route, and if there is a disruption, it will ask you to select the another route. Transportation flexibility, service level reliability, network resilience, and high reaction speed. If something happen, it will tell you in the advance. If there is a problem, it will predict that unexpected event so that your reaction speed is high. Multi-column inventory management. Again, this is related to the inventory. You will get the real-time information about the inventory. Okay. Many times if you take the example of warehouse, okay, so as I said yesterday, I talked about that cold drinks example. When you scan it, and the inventory level is updated, but what happens? Sometimes the warehouse, if you look at the inventory level at the shelf, and whatever the inventory available at the at your platform, whatever the tool you are using, it doesn't match. Why? Because of some issues like perishable nature of the products or expiry date or something. Suppose you are keeping the products on the shelves, nobody is buying it, so after their expiry date, you dispose them. Okay, so that's why transparency in the inventory is very important. This digital twin, it provides that transparency. It reduces the inventory, improve the service level, reduce the lead time. Risk management, again, supply chain transparency, and then it will predict the unexpected event, disruptions. If something is happening, suppose you are moving your goods from Asia to Europe with the help of Red Sea crisis, it will see the previous events, previous historical data in the last 10 days, 15 days, and AI will suggest you, there might be chances that your ship may be attacked, because of these reasons, so don't go with this road, go with another one. Outdoor vehicle dispatching, again, fleet transparency. Suppose if you want to know how much stock or how much load in your vehicle, you can do that as well. With the help of all these IoT devices, you can find out what is the utilization of your fleet, and you can maximize the utilization. That's fleet transparency. Service reliability, again. Warehouse management, inventory transparency, storage flexibility. So many applications are there. Higher reaction speed. Production planning, production transparency, based on your supply, demand, how much production you want to make, how fast you can make, how much resources you need to make that one. If you don't have the resources, what other options you have to make that production. Some of the applications you can see here. Manufacturing, design customization. Manufacturing, suppose when you launch new product, you don't need to go with the costly prototyping. You can make a digital twin or one digital model basically, and you can play with that model. You don't need to make a real replica of that model. Then simulate and validate each step of development. Different steps of development, you can simulate each one. Predictive maintenance, virtual monitoring. Similarly, you can see aerospace, automotive, simulation of aerospace, automotive. Just now we talked about Apollo 13 example, how they used the simulation to, to bring back those crew. Construction, real estate, project planning, logistics, utilities. So important one is healthcare, diagnosis and therapy, preventive treatment. Okay, nowadays these digital technologies they are using to find out technologies they are using to find out technologies they are using to find out some cancer to to bring back those crew. Construction, real estate, project planning, logistics, utilities. So digital the warehouse, and you can see that how it is affecting the performance. Creating an optimum logistic network, optimizing just in time production, predicting packaging materials as well, those kind of things. Then product design, as I already shared, improving design customization. So before going to the prototyping, you can play with the design their digital model, improving the equipment performance, reducing the number of prototypes. Process design, again improving shop floor performance, optimizing machine performance. When you get the when you do the predictive maintenance, basically the performance of those machineries will automatically improve. Preventive maintenance. So impact, what is the economic impact of digital twin? Tell me, what happens because of the because of the digital twin? Okay. Economical, yeah. You need a huge amount of investment for those IoT devices, cloud computing, AI, and all those things. But long term, if you see, you can get the benefits from that one. So, what are the impact? Enhanced efficiency and productivity of your supply chain. You can optimize the processes, minimize waste. Minimize waste means bottlenecks in your supply chain. You can minimize food waste, improves the maintenance forecasting, leads to higher output and cost reduction. When you reduce the bottleneck, when you automate the processes, obviously productivity will go up and your cost will go down. Better product quality and innovation. When the quality of your machines, the life is good, obviously the quality of product quality will increase. Virtual testing and simulation for faster product development, improves quality control and accelerate innovation, improve decision making like real-time data insights, enhance resource allocation and scheduling. Suppose you know that well in advance there might be the huge demand coming up from your customers. You can accordingly manage your resources. You can hire the temporary workers. You can increase the fleets, all those things. So real-time insights, based on those real-time insights, you manage your resources. Leads to better business outcomes, new business models and revenue streams. Sometimes you suppose during COVID-19, many companies, earlier the companies which were not selling the online products, but because of this lockdown and border closures, many companies they started, their online platform as well. So it enables data-driven services, predictive maintenance, remote monitoring, expand the monetization opportunity, job creation and skill development. This is very important. Many students they think that okay, because of AI and all those things there is no need of our job, and many of you are from the mechanical department, so don't think in that way. So some hard working jobs, the AI will do that job, but smart work basically if you want to analyze the data, find out the insights and trends and all those things, because whatever the the use of this AI and all those technologies, at the end if you look at the managers, they don't follow all the blindly this AI and all those things. They will check whether it is providing the good results or not, because if input is wrong, if garbage in garbage out, if your data is wrong, okay, if you don't have the good amount of historical data, AI will not perform well. So in those cases you need your experience as a manager or as an employee. So you need to build your skills in that one. Data analyst, data scientist, those kind of things. Don't now go for the regular kind of jobs. Okay, logistics manager, all those things. Risk management, another very interesting the scope. New roles in DT development, digital twin development, data analysis, cyber security. Automation may replace some traditional roles. Robotics, yesterday I have shown you one video of Ocado. Okay, so but you need to see how the you can improve your skills to manage those robotics, to connect that the robots with the other technologies available in that warehouse. So digital twins drive economic growth through efficiency, innovation, and new business opportunities, but it will also reshape the job markets. And as a students, you need to build those skills. Environmental impacts: reduce the resource uses, because you are optimizing the resources with the help of AI tools. It will reduce the resource usage, optimize the material and energy consumption, minimize the food waste, all the bottlenecks, enhances the efficiency through process simulation, lower emissions and pollution. Okay, electric vehicles are using, you are optimizing the routes. It will reduce the cost, time, emission. Greenhouse gas emission, industrial waste, real-time environmental monitoring. You can find out scope 1, 2, 3 emissions of your company. Sustainable design and development, eco-friendly products and processes, all those things. It's drive the sustainability by optimizing resource use, emission reduction. So this is the framework, supply chain management digital twin framework. If you want to implement the framework, so Ivano, again the same professor, he has proposed this 7 component based framework where they focused on the technologies. So technologies, you can see all the technologies. We discuss only the key technologies like IoT, cloud computing, but there are some other technologies are important. For example, 5G. Why do you need the 5G for digital twin? To transfer that information. That's why. So you can see all those technologies here. Management, what is the role of management, top management in the digital twin implementation. Then you have got the people. As I said, as an employee, you need to improve your skills. Then you need to update your knowledge. Organization level, modeling, what kind of modeling options are there, machine learning algorithms, optimization, task, what kind of problems we can solve, and the scope. Any logistics, important bit. So any logistics, basically this is a software tool where you can model your supply chain, you can optimize your supply chain, you can do the simulation, you can create some what if scenarios, you can do the risk analysis as well. And you can manage them with a digital twin. Why digital twin? Because there is an option, you can connect this tool with your physical world and the data will directly get from the physical world. So you don't need to directly enter the data. If you have got the ERP or some other tools in your company, you can connect those tools directly to this software, and then it will automatically update the your system, automate the system. It integrates the supply chain design, optimization, simulation with your operation data so that you can analyze, improve your network end to end. What is the benefit of, what is the beauty of this tool? Does anybody know? Who uses this Arena Stella? Am I right? Can you do the optimization in that model tool? Is there any tool available where you can do the optimization and simulation together? As per my knowledge, except any logistics, I don't know. Okay, I have used the Stella, Arena, FlexSim, so many other tools, in the past. But as per any logistics, basically this is an extension of the any logic. Does anybody know any logic? Okay, so any logic is basically that tool is for the simulation purpose, discrete event. Okay, you can do only the simulation there, any logic, and any logistics where you can do the optimization and simulation together. You can design the model. You can initially, suppose you want to optimize it, you can optimize it, and then suppose you want to develop some scenarios, what if scenarios, you can create the what if scenarios, and everything is interconnected. So it is based on the discrete event simulation. I already told it is not based on the agent based system dynamics. It is based on the discrete event. Website is here, and the good thing is that personal learning edition is free for use. As a student, you can download the personal learning edition. So there are some constraints on the personal learning edition, like You cannot model the complex problem there. Complex problem means supplier, you can go maximum 3 supplier, 8 or 10 DCs factories you can go, and 100 customers. You cannot go above 100 customers in the personal learning one. But that is sufficient for the understanding to learn how this the tool works. And once you get that, then if you are the IIT, if they get the academic version, then you can solve the complicated problems as well. Okay, so what kind of problems you can solve? Basically, where should we locate manufacturing sites, distribution center, warehouses? How should we deploy transportation policies, less than truckload, full truckload policy, or if you are in other policies, you can do that. Which resources do we need, man, machines, all those things. What if we introduce new products? Suppose you have got the existing products and now you want to introduce new products. You can do that. Then what if suppose one of the suppliers stops supplying you the products? That kind of thing. What capacity do we need to store our goods? What if we lose our key supplier? Then so many things we can do. This is really, really powerful, user friendly. Why I'm saying user friendly? You don't need to code anything. It is just drag and drop option. If you want to create the supplier, select that icon, drag it where you want to create the supplier, create the customer. When you create the customer, then it will ask you what is the demand of that customer. Then you have the option whether it is a deterministic one or stochastic one. Just define the parameters. So it's not, because at the back end it uses all your Cplex, branch and bound algorithms to solve the problem. For facility location, it uses the center of gravity method to solve that problem. For optimization, like your Cplex, Gurubi, it uses the branch and bound. This tool also uses the same thing. But you don't need to define those parameters, because constraints, all those objective functions are already inbuilt in that tool. You don't need to, like in Python or Cplex, Gurubi, you need to code it basically. What is the objective function constraint? It is less than, greater than, all those things. And this is AnyLogix based digital twin. Again, the framework, you can see the pre-post data. Okay, so what is the technology we need to collect the data, and then post processing, what capabilities we can do, simulation, again modeling, what kind of problems you can solve here. And again another framework, physical layer, digital layer, and how these two the physical and virtual model are connected. This is the digital supply chain twin layer. Here you can see that it provides some proactive supply chain optimization. You use those digital supply chain twin there, and then you analyze the performance, sustainable performance, basically economic, environmental, and social. Okay, so this is a case study. So what you do, I will give 5 minutes basically. You don't need to read the whole case study. I will tell you what is the basically. Read the section 4, just 1 or 2 paragraphs. Section 4. I will take 10 more minutes, guys. Is there any problem? Is it okay? Okay. Read section number 4. One or two paragraphs. Just understand what is the case. I don't know how many copies are there. If there are less number of copies, if you just manage with your friends. Just paragraph and then information given in that. Done? Okay. What is that case study? Tell me. What is the supply chain? Agricultural supply chain. How many members are there? 3 members. Which are they? Supplier means what? Farmers. What do? Basically, they grow the cauliflower. Okay, so farm suppliers, farmers in southern Italy. Distribution center. How many distribution centers are there? Only one. Am I right? Okay. Customer nodes in central and northern Italy. The supplier handles. Suppliers means farmers. They handle the planting, growing, harvesting, storing, and distributing of cauliflower. So product is cauliflower. Distribution involves fleet vehicles transporting products to the DC and from DC to the customer. Operational details. Harvesting is normally done in only a certain period from December to April. Okay, so based on the planting period, you need to manage your harvesting during December to April. Harvesting is time sensitive and depends on planting schedules. Okay, if you don't harvest it on time, so you may lose the crop as well. So harvesting is time sensitive. Products can only remain in storage for 3 to 5 days because of perishable nature of the product to meet the contractual quality standards. You cannot keep the product more than 3 to 5 days. Okay, max 5 days. Historical data is available. They haven't given the historical data in the case paper, but they analyze the data from the 3 seasons, 2019-22, 22-21, 21 to 2022. The company wanted to analyze the impacts of the various disruptions, because if you look at the historical data, this comes into the COVID-19 period. So company wanted to analyze the impact of the disruptions based on the historical data, because there was a huge demand during the first, second lockdowns everywhere. So they wanted to see, analyze the impact of the disruptions. What happens, suppose you cannot harvest the crops because of the labor unavailability. What happens, suppose your distribution center is closed? How it will affect your profit? What you can do to manage that disruption? And similarly, suppose the link between DC and customer, if it is disconnected, if suppose border closures and you cannot move the goods from the DC to the customers, what can you do? Okay, so they wanted to analyze those disruptions. So what they did, disruption. First, they consider the 3 disruption scenarios. First disruption scenario was supply side disruption. Because of COVID-19 outbreak among field workers led to harvesting disruption and food waste. They did not have the company did not have the sufficient workers to harvest the crops. It means it is a food wastage basically. Second one was middle side disruption. Because of lockdown and border closures, and then this outbreak, the DC was closed for say around 10 days, 20 days. They wanted to see the impact of the DC closure on the supply chain performance. Okay. Third one is the demand side disruption. Demand side disruption means the link between the DC and the customers, it is disconnected because of the border closures and lockdown. So transport connection between the DC and customers due to government restrictions. So these were the 3 decisions disruptions they wanted to analyze, but they had the backup plans, response strategies. Suppose what are the response strategies company had? Suppose supply side disruption, because of unavailability workers, supplier signs the pre-contract agreements with the additional seasonal workers. They had the temporary workers, so they, in order to deal with this workers problem, unavailability, they had signed the contract with the additional temporary workers, and those temporary workers will come and pick up the that cauliflower in case your main workers are unavailable. Second one is the DC. If your main DC is closed, activate the additional distribution center, backup distribution center, to manage the disruptions. What is the third one? Transportation disruption. Now they contacted another third-party logistics provider to manage that logistics disruption. So these are the 3 response strategies to manage these 3 disruptions. So they wanted to analyze the impact, and then they consider these indicator KPIs. What our first indicator was indicator 1, it was environmental sustainability. What is that? Unharvested products and total products. How much cauliflower or products available, total products, and because of that unavailability of workers, how much product we lost. Food wastage, unharvested products, total products. Suppose total products are 500, and out of that 500, suppose you don't harvest the 200 or 300 kg, whatever it may be. So it is related to the environmental sustainability. Why it is related to the environmental sustainability? Food waste. You are wasting the food, basically. So environmental. Second one is the products perished in the inventory and harvested products by harvested. So DC can keep the products maximum 3 to 5 days. Suppose because of borders and lockdown, you cannot move the products, that products will get spoiled into the your DC. So how much products perished in that inventory divided by the total stock. So that is again environmental sustainability. Third is the social sustainability. Suppose during COVID-19, there was a huge demand for the food, essential products. If you spoil the that food and crop, so basically, what is the total demand, and out of that total demand, how much you fulfilled? Fulfill demand by total demand, it will give you the social equity. So that is a social sustainability indicator. Fourth is the revenue. I hope you know how to calculate the revenue. Sales price into the how much products you sold. That's your revenue, economic sustainability. What is the fourth? Resilience. What is that? I4 into N. I4 means revenue. N means revenue during the normal time without disruption. Suppose revenue during normal time is 1 million. Okay? Just assume. And what is this minus I4D? D means disruption. Revenue during the disruption. Revenue during the normal time is your 1 million. Revenue during the disruption is 0.5 million. How much was loss? 0.5 million is your loss divided by the inventory, revenue during the normal time. So this shows the percentage basically. Suppose your percentage is higher, means your supply chain is less resilience. Okay, if you have the more loss because of disruption, it means that your supply chain is not resilient. That's the one. So what they did, so basically they model this problem in the any logistics. You can see the supplier, distribution center, customer. This is the real life network. Okay, and then they collected the data. You can see they initially collected all the data here. Then they decided the KPIs, economic, environmental, social. Then they decided the disruption here, 3 types of disruption. Then they decided the response strategy. Then they model the network here, basically done the scenario analysis, and then they analyze each scenario here. Okay, so again the real environment. This is the digital environment. Step 1, data collection. Real supply chain awareness, data collection, supply chain KPIs, events. It goes to the digital one. Supply chain modeling for digitization, supply chain simulation, and so on. And then this digital environment provide decisions, then you execute to manage your real system. So what are the scenarios they consider? They consider, how many scenarios, 7 scenarios. Why? Scenario 0. Scenario 0 means, what is it? Scenario 0. Can you see D1, D2, D3? What is D1, D2, D3? Disruption 1, 2, 3. RS1, RS2, RC3, response strategy. Scenario 0 means there is no disruption. No disruption, no response strategy. Normal operation, normal. Everything is working fine. Scenario 1. Scenario 1 is D1, disruption 1. Workers unavailability at farms. You cannot, pick up the crops. That's the one. And then you are not adding any response at this moment. Only you are trying to identify the impact of that disruption. Disruption, scenario 2, the impact of DC closure, D2. Scenario 3, impact of transportation link problem. And then what is scenario 4? Tell me. Disruption 1, in addition to that, response strategy. Means you are considering the unavailability of your regular workers, but you are also considering the backup, your agreement with the temporary workers. Same, the scenario 5, it suggests the D2 and D5, D2 and RS2. RS2 means your backup DC. And then finally, scenario 6 is your transportation link problem and third party. And what is the scenario 7? All 3 kinds of disruption. Why did they consider all 3 kinds of disruption here, guys? Any idea? COVID-19, that's why it is called special kind of event. Why? Because in normal situation, you experience the risk from one side. You have the problem from supplier side, demand side, or something like that. But you don't face the problem risk from all the ends. But during COVID-19, we had the problem from supply side, we had the problem from demand side. Our distribution centers were not working, and that's why this is called COVID-19, means simultaneous occurrence of the events. So they consider that one, and what they did find, look at one, I1 means revenue one. In scenario 1 and 4, scenario 1 means unavailable of workers, and scenario 4 is additional workers. Simulated outbreak among workers causing 10-day unavailability. They assume that the main workers were unavailable for 10 days, and what was the impact? The 12% of the revenue was affected because of that one. Can you see this 12% was disruption? Then when they activated the RS1, additional temporary workers, their revenue come back to the original level. So that's the first one. Second one, scenario 2 and 4, DC closure. So impact was 7% of products wasted due to the quality issues. They had activated the additional DC but did not eliminate it completely. They didn't come back to its original position. They activated the DC but they did not come back to their original profit revenue. Third one is scenario third. Stimulated transporter outbreak causing 1 week disruption, affected 15% of demand unsatisfied. Reduced this impact to nearly zero when they went to the third party logistics provider. And in revenue 4 scenario, revenue 4 and R1 response 1, revenue evaluation across all scenarios with correctly delivered products. Response strategy proved effective in managing disruption. R1 response strategy 1 revealed low resilience to manpower shortage disruption. So among all three response strategies, the response of the impact of the RS1 has the basically the lower resilience, means it took additional time to come back to the original position. And these are the references for this one. So today we just discussed this one, but in the next, not tomorrow, maybe 3-4 days, we are going to discuss how to design that model in the any logistics. I will tell you step by step how to create the model, how to do the optimization, simulation, everything. Okay, so you can keep the copy of this one if you want. You can see, you can find many papers on the any logistics. You can refer my papers as well. I hope you had enjoyed the session, and if you have any doubts, questions, I am here to answer them. Saurabh, any updates from online participants? No question? Okay, thank you.
At the end of the Gyan course, I will share the PDF file of all the PPT. Okay. Even if you want, you will get the video of the lecture also. Okay.
You can go, guys. Yeah, if you want to do. Yeah.
Tomorrow the session will be from 11 to 1. Okay.
Tomorrow, Shivratri, that's why. Do you want the session or not?
Session to वो वहाँ से reschedule करना होगा मुश्किल है.
So just come for 2 hours. Okay.